The Department of Transportation calls this structure Pier 1 South, and in the background is Pier 1 North. Together they will bear the bulk of the weight of the main span of the new Sunshine Skyway Bridge. They also both have cracks in them. Now, these piers, like the bridge that will one day stand upon them, are of rather unique design. They are basically big, thick concrete discs that are supported by pilings which extend deep into the bottom of the bay. What makes these piers unusual, at least to a layman like me, is that they are hollow. There is a large round chamber inside called the cone, which is accessible through a shaft in the top slab. The theory is that the massive weight of the bridge will radiate down through the walls of the piers to the pilings. Last August, after construction of the piers was completed, DOT inspectors entered the cones and discovered cracks in them. There were cracks in the walls and cracks in the floors. A week or so later, both the cones were flooded with seawater in an effort to create a pressure against the inside walls of the chamber that was equal to that being exerted against the outside by the water of the bay. DOT divers then re-entered the chambers and discovered that the equalization of pressure had not arrested the cracking, but rather additional cracks had appeared. There were now new cracks in the walls of both piers, the floors of both piers, and in the top slab of Pier 1 North. This week, the DOT divers submitted their report to DOT Project Supervisor Glenn Ivey. The report documents and delineates these cracks. There are dozens of them. But the cracking apparently comes as no surprise to Mr. Ivey, nor does it seem cause for concern.
Yeah, I expect three things out of concrete. I expect it to be gray, expect it to be hard, and I expect it to crack.
The foundation piers that will support the new Skyway Bridge, then, are satisfying the expectations of its project supervisor. They are gray, they are hard, and they are cracked. Shrinkage cracks is what Mr. Ivey calls them, a natural phenomenon, he explained, which occurs as the concrete cures and contracts. Natural, perhaps, but not necessarily necessary. This is the last span to be built across the bay. Of course, some of it is in the bay now. It was knocked down by a ship called the Summit Venture. But this bridge was cracking and crumbling before it was struck by that ship, a condition which some say contributed to its collapse. What's left of this bridge stands alongside a bridge that still stands, the first bridge across the bay. Finished in 1954, it is 15 years older than the one that was knocked down. But the only cracks that DOT inspectors say they have found in this baby were caused by the explosions that were set off by demolition experts to clear the channel of the debris that fell into it from the collapse of the other bridge. Perhaps that's why one of the people who built that bridge was so disgusted with the construction of the one that fell down and is so concerned about the construction of the one that's now being put up. He is Art Goodale. He is a civil engineer, and he was the general superintendent of the construction of the first bridge. He has been so vocal in his criticism of the subsequent bridge construction in the bay that some people call him a crackpot. But he asks those who would question his credibility to bear in mind that the bridge he helped to build hasn't had a problem with cracking. I asked Art why he thinks the new bridge does.
It would seem nowadays that they're striving to get a concrete that has a much higher early strength so they can pull forms and so on. But this high early strength means that the concrete is curing faster and producing more heat, and I believe that is subject to more shrinkage cracking.
But shrinkage cracks are not necessarily a sign of weakness as stress cracks might be. Why then should there be cause for concern?
Because inside the face of that concrete are reinforcing bars. And these reinforcing bars can be attacked by the salt water and deteriorate and swell up and cause more cracking. And as we go along, the pier deteriorates just as the second span did.
When I asked the DOT project supervisor what effect the salt water would have on the rebar, he explained,
For corrosion to occur, you need a number of things. And should you change one of the requirements for corrosion, then it doesn't occur.
In other words, underwater there's not much oxygen, right?
Yes, there's oxygen in water. There's oxygen dissolved in water. All of our marine life depends on it.
Dr. John Ratliff is a professor in the School of Engineering at the University of South Florida. His area of expertise is corrosion. As there is oxygen in the water, what then could we expect to occur if the water reaches the rebar?
Well, the rebar would more than likely begin corroding, and the corrosion product occupies a larger volume than the metal that is corroded, and so therefore stresses develop around the rebar, which usually causes the concrete to crack and spall off the rebar.
And if that process, by larger volume, you mean it gets bigger?
Yes. Mm-hmm. The rebars actually grow in size.
How much bigger can the rebar grow in size?
Enough to cause sufficient stresses to blow the concrete off the rebar.
God, cracking in the new slab of Pier 1 South does not appear as yet to have stayed on. New cracks appeared overnight in several locations that had been documented earlier.
This is Dr. Bill Skelton, also a PhD at the School of Engineering at USF. His area of expertise is concrete. I showed him a copy of the DOT Divers Report, and Dr. Skelton's spontaneous reaction while reading it indicated to me that he interpreted it differently than did the DOT. And as Dr. Skelton is an expert on concrete, he was especially interested in the photographs the report contained. Actually, photostats of photographs, as the DOT obviously couldn't give me the originals. They show strange formations on the floor of Pier 1 South. The material is what engineers call efflorescence. Customarily, it leaches out along cracks in concrete. But neither Dr. Skelton or any of his colleagues I spoke with at USF have ever seen it in this configuration, like stalagmites on the bottom of a cave. Samples of this efflorescence, when analyzed, can tell engineers a great deal about what is happening inside the concrete. For instance, if the sample contains any quantities of sulfur, it can mean that the concrete is dissolving, and that's without any problems that may be caused by corroding rebar. At this point in time, the Department of Transportation has not taken any samples to be analyzed. So before I went to see the experts at USF, I came out here to Pier 1 South and dove the cone. I also took my underwater housing along to get some of our own pictures. Here's one of the cracks in the wall. This one appears to extend all the way from the floor to the ceiling. You can see the efflorescence that is leaching out along the crack, and this reddish-looking area may be the corrosive bleeding the report refers to. The report also refers to pre-drilled holes in the floor of 1 South, some with exposed steel rods. There can be no question that corrosive forces are at work here. And finally, footage of the strange efflorescent stalagmites. And that's my foot, to provide a reference to the stalagmite size and to knock it down to get a sample. Back at USF, Dr. Skelton took me over to the chemistry building where his colleagues there subjected it to 3 different procedures, all too sophisticated for me to understand, much less explain. But the DOT should be glad to learn, and I'm relieved to report to you, that the tests, while not entirely conclusive, did not reveal the presence of sulfur or any other element that could threaten the integrity of the concrete. As the material forming the stalagmites appears then to be benign, we can only attribute the extraordinary shapes to the fact that this is the first time efflorescent leaching has been observed at the bottom of a stagnant body of water, where there is no current to carry its fragile fabric away. But remember, the water may not be totally still. There is evidence it may be seeping through cracks in the concrete and corroding the rebar. There is also no evidence that the cracking has stopped. If such is the case, and it is allowed to continue unchecked, what consequences can there be?
Well, there's a lot of things that can happen. Obviously, the worst, of course, is for the bridge to fall down. Other things that could happen would be distortion of the foundation, where the bridge would move with the winds and the forces that are put on it. The bridge probably would not be stable.
As you are by now aware, we have devoted an unprecedented amount of time to this story for a half-hour newscast. But one Skyway Bridge has already been the source of an unprecedented disaster for Tampa Bay. I'm not trying to alarm you, just to alert you to what I perceive as an apparent lack of concern on the part of the powers that be at the DOT. Anybody who watches Newswatch 8 regularly and is familiar with my work knows I'd much rather be covering the nautical news stories I customarily do, or roving around 8 country doing feature reports. Had one official of the Department of Transportation expressed to me a fraction of the concern that the experts at USF did, I would have been. I'm Bob Hite, Newswatch 8.